Hello and welcome to this month's NEIMME lecture on the subsurface aspects of the Gateshead mine water heat scheme given by Dr. Charlotte Adams of the Coal Authority. Last month's lecture, we had a talk from the A1 Locomotive Trust on their brand new steam engine. Great attendance. I'm sure this will get many more views online. Range of fantastic questions. Vote of thanks by David Granger and closing remarks by Steve Martin. We're looking forward to our local heat of the IMME Young Persons Lecture Competition. To find out more, please look up the competition online. And if you're interested in entering, then do please get in touch. We have a chartership evening with information from IMME and the Institution of Mechanical Engineers on becoming chartered via those particular institutes. If you're interested in finding out more about professional chartership and how this can further your career, please do tune in. Our March Institute lecture will be joint with the Nuclear Institute, and this is on the vibrant nuclear renaissance being provided to us by the next new generation of small modular reactors. And our April lecture will be joint with the Institution of Mechanical Engineers, and we'll hear from Dr. Martin Smith on the future of machine learning for mechanical engineering. Bit of an announcement. We are now a partner of the Geothermal Energy from Mines and the Solar Geothermal Heat, or GEMS project, based at the Durham Energy Institute at Durham University. We've been working with them for a while now on the providing advice about the mine workings involved in the various scoping projects, and we're looking forward to further involvement as well. It's fantastic to be working with Professor Jeroen van Hunen on this. If that's not enough for you, well, there's much more online. If you want to find out more about our events and our work, then do please sign up for updates via our various online channels. There's plenty on. We do lectures such as the one you're attending tonight, a range of important regional conferences, our annual dinner and symposium, bringing together engineers and scientists from across the north of England, our CPD events and socials, as well as our field trips. The best way to support our work and to get involved further is, of course, via membership. We have plenty of fantastic membership benefits from post-nominal letters and discounts on various publications and trips. So if you want to find out more, please do visit mineinstitute.org.uk/membership, and you'll be able to download a membership application form from there. And I'll hand back to Steve in Newcastle for what should be a really interesting lecture.
So there we are. All I can do now is to introduce someone who we all know very well here at the Institute, and we've all been sitting with bated breath for quite a while now to find out what new developments are happening. So can I pass you across now to Charlotte Adams. Thank you, Charlotte.
Thanks very much. So evening everybody, and thank you very much to the Institute for the invitation to join you here tonight, and thanks to you all for coming as well. So it's great to be back here and talking about something that personally I've been interested in for at least the past 2 decades. So to see it finally happening is great. And this has very much been a collaborative project. I'm focusing on the aspects that we did on the subsurface aspects. And I've included Jim Gillen from Gateshead Council, so he hasn't approved this presentation, so don't hold him to task on anything I say, but I wanted to just include him because he's been our key contact at the council and really drove this project forward from their side. So I'll be covering a little bit about the Coal Authority. I'm sure most of you know what we do, but we do get asked still, what do you do? And we didn't even know we had a Coal Authority. I went into the butcher's in my Coal Authority fleece, and he was like, "Oh, blimey, I've never heard of that." So, I will give you a little bit about the kind of things that we cover, talk about the resources that we have and the different ways in which you can access mine water to get heat from it. Talk about some of the things you might want to think about if you're starting your own projects or considering doing one yourself. And also, it's, as the title suggested, it's a case study really on the Gateshead project, which is what most of the talk will be about. I had an alternative title for my talk, which was making the Baltic less Baltic, but I thought I better have a serious one. But I always come up with really boring titles for things. So yeah, I think I might try and switch to using something a bit more creative in future. So a little bit about ourselves. We have some statutory functions at the Coal Authority, and those are mainly protecting both people and the environment. So on the protection of people, that's things like inspecting mine entries and also tips. So we've been busy inspecting a lot of the Welsh tips after some of the rainfall events we've had over the last couple of years. We've been doing some colleagues have been doing some really good work down there. Obviously dealing with surface hazards, because we still get those appearing on a regular basis. And then we've got our kind of report side, so any kind of property transactions require mining reports. We do a lot of those. We also issue permits because we own the infrastructure, so anybody that wants to do something like drilling and grouting operations or access or drill through our workings for any reason, we permit that as well. In terms of protecting the environment, we have an environment team that deal with and manage rising mine water across the UK. And we have around about 80 or so treatment sites. On total, we kind of treat this 122 billion litres of water. So we do handle quite a lot of water. We're looking at uses for the water. And we're also looking at products from the mine water treatment. So the ochre that we produce, we've recently had success in getting that into the anaerobic digestion market. So we now have a use for some of our ochre. So we're trying to reuse the water, the ochre, and also the heat. And then we're trying to offset costs, because obviously a lot of these things that we manage are liabilities. So we're looking at ways in which we can offset the costs, because obviously a lot of it's funded by the taxpayer. Our team itself isn't funded by the taxpayer, so BASE is our sponsoring department, and I know it will have a new name shortly, but we are actually like a self-funded team, almost like a consultancy within the organisation. So we offer our advisory services on these type of projects, so we're not centrally funded as one of the core functions, which does restrict some of the things we can get involved with because we have to cover the costs of our time, but there are bits and pieces we can do you know, on an initial basis as well, so don't be hesitated in asking us to look at anything for you. In terms of what we have in the UK, there's around about 23,000 disused deep coal mines in the UK. I'm sure many of you will be very familiar with lots of those. And of course, the majority are now closed. Unfortunately, a lot of the shafts are filled and capped, and doing what we do now and knowing what we know now, we maybe would wish we could have kept a few more of those open to access the water as the water levels rose for these kind of projects we're doing now. And there are opportunities, because obviously there's other areas in the world that have yet to abandon their coal. And it's something that Norman and I were working on just pre-pandemic. He was due to go and give a paper that we'd put together on how to kind of plan for energy recovery before you abandon your mine. So there's lots of information and knowledge sharing we can do as well. And we've got about a quarter of properties on the mine, on the coal fields, or the coal mine reporting area as we refer to it. And you can see that's in those kind of polygons with the white outlines there. And you can see that many of our large towns and cities are underlain by the disused workings. And that's not surprising, because those economies and those cities grew from the strength of their coal resources. And so we're now in a situation where we have the resource quite well aligned with the areas of heat demand as well. So that's really good that for the coal mines, certainly we have that good correlation. So in terms of thinking about mine water, it has been a liability. We have to handle a lot of it. Pumping costs a lot of money, treating it costs a lot of money. But perhaps there is an opportunity to reuse it. And this idea was started off by a guy at the Coal Authority, and I kind of joined the Coal Authority 3 years ago. I'd been at Durham University before that. And I really wanted to work with Jez Crooks, who was leading this work then. He was also leading the reuse of water and the reuse of ochre. So the mine water heat, although it's something I'd been talking about for 20 years, and everyone was like, oh, go away, we've got cheap gas. You know, we're not worried about carbon emissions at this time. It's never going to work, it's too expensive. Now things have changed. Obviously, it's having more of a moment. And he'd seen that, and he was leading that. So he sadly passed away 2 years ago. So our legacy in our team has been to try and just push through all these amazing things that he started, and the project I'll talk about was one of those. So there's lots of reasons for doing this. So we can use it to offset gas consumption. We can use it as another source to provide heat, which will obviously reduce carbon emissions. And because some of the coalfield areas are still in areas where there's fuel poverty or high levels of unemployment, then there's potential there for this levelling up agenda that's going forwards. So there are opportunities there. And the fact that it can provide a reliable and local source of heat. And the thing about heat is it doesn't travel far, so the benefits have to be realised locally. Whereas when the coal was mined, traded, maybe left that area. So apart from the employment and things it created, the benefits to the local people maybe ended at that point. Whereas with the heat, because it can't be taken elsewhere, it does have to benefit people locally. So generally people are quite positive when we talk to them about this. So if you're looking at the different types of geothermal, and the other reason I was interested in this, because when I was at Durham I was working on all kinds of geothermal, and deep geothermal was always of interest to me, and it still is. But in terms of de-risking and trying to get a geothermal industry going in the UK, my feeling was that to use the mines was a good starting point, because if you drill a deep geothermal well, you know how warm it's going to be at 1.5 kilometres or deeper, but you don't know you're going to get the flow of water, which is what you need to get the energy to the surface. So my rationale was, if we use the mines, we know the systems that did flow water because water had to be managed. Admittedly, we don't know what's happened to them exactly post-closure, and the temperatures are lower, so you're not producing electricity, you're looking at heat, but you're kind of de-risking it a bit. So that was the rationale that I was working on at the time. Different ways in which you can access it. So you can put a closed loop heat exchanger into the mine. So unfortunately, we had a mine collapse a couple of years ago, a shaft collapse in a guy's back garden in the Bristol area. And so part of the treatment of that shaft has been to put in a closed loop for him that he can then connect a heat pump to and use it to heat the home that he was rebuilding at the time. Unfortunately, when this happened, I think he was adding on an extension and they found the shaft. So there are, and that's something that our permitting team would come in on as well. So if you wanted to use the infrastructure to put your equipment in, that would require permitting, and they've been involved in doing this for him, as well as our public safety and subsidence team, who actually sorted out the collapse as well. Open loop boreholes, so I won't say too much about those because that's the case study I'll be talking about tonight, but as the name suggests, you're actually using the water directly there and you're drilling boreholes to access it. And then direct from mine water at surface. So I mentioned that we've got about 80 treatment sites across the UK where we either pump water or it flows under gravity. And those could be the focus of heat systems. Durham County Council are trying to take one forwards at Seam Garden Village, which would use the water we pump from Dordon as the basis of the heat supply. So just things to think about when you're considering a mine water heat project. And there's lots of things. This is just probably a few of them. I'd be on all night if I went through all of them. But the age and the depth of the workings is really important because that links to how accurate the mine plans are. So the Gateshead area, the plans were very old, and I'll show you those shortly. That does affect the accuracy and the accuracy to which you can drill to hit the targets. And you also need to understand what the mine plans are telling you. Just because there's a mine there, you need to understand what features within the mine you might want to access, and also how those features are connected together so that you can have somewhere to take the water from and somewhere to put it back to. And there does need to be a connection between them, otherwise you'll have pressure differences building up. And although you've got to have that connection, you can't have it too close together because the water has to have time to be reheated as it goes around the circuit. So there's a bit of kind of knowledge, bespoke knowledge, which to be honest there's not a lot left of, and we need to kind of capture as much of that as possible on, interpreting mine plans and looking at the mining information as well. Drilling, it's important which drilling contractors that you use. It's good if they've had experience of drilling in coal fields, so they're aware of what to do when they encounter voids, or if they have to go through aquifers in order to get to the workings beneath them. So it's very important to check the quality of your drilling contractor, and also that they can drill in a straight line, because we've had issues where that hasn't happened. Sometimes you don't want them to. You might want to deviate to hit the target, but if you're wanting a vertical borehole, you need to check that you're going to get one. Coal mine gas, I'll talk about that a little bit with respect to the project we've done, but obviously you need to undertake a gas risk assessment because gas may still be present in some of the workings that you're drilling into. Pumping tests would be something you do once you've got your boreholes, but you may want to start with exploratory boreholes and you can learn a bit more about the system before you're committing yourself to full production boreholes. And that can tell you something about chemistry. Is the water aggressive? So often mine water it can have slightly lower pH, it can have salinity, and it can have quite a bit of iron in it. Obviously the salinity and the low pH can cause corrosion, and the iron, if it's exposed to the atmosphere, that can cause clogging by precipitation of ochre, which is exactly what we're doing in our treatment systems. We are precipitating ochre because we want to get it out of the water column. But in a mine water system, you want to keep that in solution. Looking at the connections you've made with your boreholes to the workings and learning about the hydraulic properties of them, and also seeing if you can get reasonable yields. And again, I'll give you some examples of that from the case study. So this is us stood on a visit outside Gateshead Energy Company's existing CHP energy centre. So they have two CHP gas engines which produce about 4 megawatts between them, and they had about 5 kilometres of heat network. And they came to us in 2019 and said, we want to double the size of our network without doubling our carbon emissions. We know we've got mines underneath us, can we use them? So that was the question, and of course my former boss, Jez, was like so enthusiastic, yes, we definitely can, so right, let's have a look and see what we've got. So we were brought in to advise on the boreholes and the testing. So it says CA there, that's not me. I just happen to have the same initials as the place I work for. So any CAs in here are definitely not just me, it's everybody. So yeah, they basically wanted to increase this network, and this would be the first mine water heat network in the UK, and certainly the largest one. And the way it works with the model they have now is that they supply their customers, so they supply commercial, municipal, and they will also do some domestic loads as well, but they undercut the market energy price by 5%, so that's how they attract people to connect to the scheme. And if you think about the domestic connects they hope to have eventually, there's a lot of stuff about people putting heat pumps in the homes, but maybe a heat pump would cost you £6,000 or so. If you've got the opportunity to connect to this network, you can still make a green choice, but it's a bit more equitable, and that seems to be quite an attractant to people joining the scheme. And because they've set up their own energy company and run this themselves, the money spent on energy stays within the Gateshead area and is used for things in Gateshead. Whereas when you've got something that's going out to the big six or the equivalent, then you can see again it's all about the local benefits. And I think on this project, the fact that they have the energy company and they've put the heat network in themselves, obviously that's been a lot of work on their part, but it has, I think, enabled the project to happen a bit more quickly as well. And it also aligns with their zero emissions targets in the future. So as part of the feasibility study, the first thing we do is we get the mine plans out, and there's just some little snips here of some of the ones we used. So the coloured polygons on there are the areas where they'd asked us to look. And we ended up focusing on this top red polygon and this one, just because there was more mine coverage in that area, and it worked better with what the council were wanting to do topside. So we kind of ruled those other areas out, and that's how we tend to approach these studies. We'd have a look at a lot of areas first, and then maybe narrow it down. So all of these areas are on the table here, and we looked at what workings were there. We found the high main seam, which is the shallowest one, was more or less everywhere, and you can see the high main plan there. And when you look at these in detail, this bit along here, so bearing in mind this plan's 1786, we're lucky we have it because there was no obligation to actually lodge your plans at that date. That came much later, as many of you will know. But actually on here, it says old workings, which are actually off in this area and not on the plan. So you think, crikey, you know, how old must they have been? So basically we find that seam more or less anywhere in the Gateshead area. So even though we don't have plans with it all on, it was more or less worked everywhere. And then the other one we're looking at is the low main or Hutton. And as Stefan was talking to me about before, there's some interchangeability, whether you're north of the Tyne or south of the Tyne or in Durham, as to what's the Low Main and what's Hutton, and maybe they're both the same thing. So that's obviously makes things a bit more difficult. I've got 2 plans out which have different names but do look identical, so we're pretty certain they are for the same seam. And of course, none of these have the depths on them either, or very sparse depth information. So we start off by looking at the mine coverage, and then we also look at the collieries that worked, so that we can see kind of what areas were worked, which bits are likely to be connected to each other if we're looking for those connections and flow cells when we start operating a system. And because there isn't any depth information on a lot of the plans when they're very old, we put together a composite section, which is the one here on the right, and that's made up from the shaft sections. So thankfully there's quite a lot of shafts in that area. There was 70 or more in the kind of immediate area we were looking. Not all of them you can get the records for, but there was enough there to give us a good idea of what geology we would expect and what seams would be present. And then we kind of produce this table, which is, again, just telling you which collieries work, which seams, which is handy for just knowing where you might want to target your boreholes. So it's all just piecing together this information. We also get hold of water level data if we have it, either from Environment Agency boreholes or from our own. We know in this area that water levels have been static for over a decade and around about 20 metres below ground level. When we started this project, we didn't know whether the Gateshead site would be in the central Durham North mine water block or whether it was in the Walker block. So the mine water blocks are basically sets of collieries that behave hydraulically in a similar way. So we generally find a similar water level in each set of workings. And there is a difference between the Walker block and the central Durham North one. But because we didn't have any monitoring boreholes in that part of Gateshead, we didn't know exactly which block that was in. So we've now found out through what we've done that it is in the Walker block. So it's not massively affected by the pumping at Kibblesworth. And although they're classed as blocks, they're not perfect blocks. They do have leaky boundaries. So there will be some water going that way, but not significantly that it affects. You know, if they were well connected, you would see the same water levels in both of those blocks, and we see different ones. So that's one thing we've learned from doing it. We had information from Kibblesworth before, so we knew something about flow rates and temperatures and water quality, but we've managed to, as I say, delineate that a bit more now. And then the workings we were looking at, so we focused on the high main workings, the shallower seam, which have the high main post, which is a highly fractured sandstone above it. We focused on that as an injection target because that's the shallowest one. And then we were looking at the Hutton Seam because that was 150 metres deep. So that was kind of the deepest seam that wasn't the total deepest seam, but it was deep enough to be a bit warmer than the high main, and it had good coverage in the areas that we were looking at. And what we found is that we see from the data loggers we have in now that we get a tidal response in both the high main and the Hutton, which is not surprising because you're very close to the Tyne there. And the high main shows a direct response, so it's in hydraulic continuity with the river effectively. And the Hutton Seam shows more of an elastic response, so it's from the weight of the tidal loading on the riverbed, which is effectively compressing the strata, and that's why we see the water levels going up and down with the tides. So from that we learned that the Hutton Seam was confined, which had implications for later on. And also, as well as the Gateshead scheme, there's another scheme operating at Lanchester Wines, which is about 4 megawatts. They have 2 warehouses. Each warehouse has its own boreholes. They're not connected, so it's not a network, but it's still quite a large mine water heat scheme. And we want to know about how those schemes interact, because that might limit the number of schemes you can have and the distance between them. So that's something we're doing research on, but I'll have a slide on that later. So for mine gas risk assessment, obviously in this area, historically there was a lot of gas incidents. So I was having a look through some of them when I was putting this together, and there was some very strange things going on. There was people throwing, I think someone threw a firework down the Redhoof shaft and killed themselves, unfortunately, because it went up. And there was a guy over in Bensham who every time he lit his fire, and this was in the 60s, his pantry door slammed shut and he wasn't sure why. And somebody made the association that there was gas under his floorboards, and by lighting the fire, fortunately, there weren't obviously enough concentrations to blow up the whole house, but it did have a kind of backdraft effect through his house. So there were things going on in that area, and thankfully at the time, people knew what it was and were able to deal with it. But subsequently, because the water levels have risen, they've been static now for the last decade or more. When we find that as the water levels come up, the gas production reduces because, as you would expect, the coal, well, some of the coal is gone, but the coal that's left, the cleats on those, that is where the gas is produced. And once the water's in contact with that, it seals it off effectively. And we've seen that in some of the boreholes that have been used by the likes of Gateshead Energy, for example, for mine gas recovery. As the water levels rise in some areas, their boreholes are now not productive because of the rising water. So we felt that because of the high water levels, because of the highly fractured nature of the high main post, which was above the high main workings, we felt that gas would have migrated to that horizon and probably dissipated maybe up dip or even through the surface, because the superficial deposits are relatively thin there. So with the gas risk for this site was relatively low. We did have one incident when the gas alarm went off, and that was when we were drilling into the Hutton Seam. It actually wasn't when we were drilling, it was when we were doing injection testing. And the gas alarm went off for just a moment and then dissipated. So we suspect there was just a little pocket somewhere that was disturbed by putting water in. People ask us about substance as well. So there's a rule and some guidance produced by Syria, which is quite good. We've also got some guidance for drilling near mine workings as well. That's more linked to maybe drilling and grouting, but it's all quite useful stuff. And that's working on the seam thickness, and maybe 3 to 5 times the seam thickness would be the zone above which you would expect the fractures to propagate. So if you've got a seam that's 1.5 meters worked, then 5 times that would be maybe how far you would expect that fracture propagation to go up. So then you can make sure that that's a sufficient distance below surface. So that's the kind of, that's what our public safety and substance team deal with. I'm not an engineer, so I'm not an expert in that, but obviously that's something we do get asked about as part of this, so we do follow the guidance for that. So anybody that comes to us with a site with really shallow seams, we wouldn't consider that. So in terms of the borehole drilling, we cored some of the boreholes because this area was a bit new to us. We knew we'd just get a load of coal measure stuff out of it, but it was interesting to us to see, and because of the uncertainties over the depths to the seams, because we had this kind of composite section we'd made, it was useful to have the core. Obviously we found voids when we hit the workings. We went through intact pillars of coal in some places, which wasn't what we wanted to find, but all still interesting. And in some of the voids, some of the material we found that was broken was actually quite rounded, so it did show you that water had been flowing through those systems, for 100 years or more. And in terms of the design considerations, we tend to, when we work with the local authorities, one of the first questions we ask them is, how much heat are you wanting to produce? And then we can work that back to a flow rate. So for every megawatt, if you're taking 4 degrees out of the water, you're going to want a flow rate of 50 litres per second for every megawatt. So we start off with that sum first. That gives us an idea of the pump size that we'd need to lift the water, and then the borehole design is kind of worked around that. We're thinking about resilient materials because of the water quality that we might encounter. If we don't have the data, then obviously we design to assume that that's there. Thinking about the depth of the pump that you might want to use, and at Gateshead it's 43 metres down, and that's because when you start pumping, obviously you get some drawdown in the system, but you've still got to maintain a sufficient head of water above the pump. So we had the pumps I think a little bit higher than that, and they were dropped eventually just to make sure there was a bit more freeboard above them. And then thinking about the number of abstractions and injections you want. So at Gateshead, because the abstractions are relatively shallow at 150 metres, they had 2 of them because they decided they wanted a bit of flexibility and resilience on the system. So it won't need to run at peak demand all the time. So the peak demand of that system will be 6 megawatts. And it means that if they want to work on one of the boreholes or one of the pumps, they can do that and set the other one aside. So it depends on what you're doing and what other alternatives you have as to what choice you make, and also how deep your boreholes are. Can you afford to double up on things? So there's 2 abstractions and 1 injection well. And then we put this spec out. We helped Gateshead to put together their tendering to get a drilling contractor to do the work for them. And we put out a basic spec. And they, obviously, we welcome their thoughts because they're the experts as well, so we see what they come back with as well. So we, Gateshead selected Drillcore to work with, so we work with them on this project. So we drilled some of the abstraction wells, and this taught us a bit more about the hydraulic performance of the aquifer. So this is a borehole into the Hutton Seam, so that was confined. So when we had a borehole in the high main seam and one in the Hutton Seam, the water level in the Hutton was slightly higher than it was in the high main. So it was confined and there was a slightly higher hydrostatic head. And when we started to pump the Hutton Seam and put it back into the high main, we saw this kind of blue curve appearing. So we did step drawdown, so where you're incrementally increasing the flow rate to see how the aquifer performs. And as we did that, it should, in an ideal world, it should stabilize out at some point. This wasn't stabilizing out, and the drawdown was increasing. And also a nearby observation borehole was showing the same amount of drawdown, so the whole aquifer was kind of behaving in a very flat way, which is not what you'd expect. Normally you would expect to have more drawdown around your pumping borehole and slightly less at the outlying ones. And this was due to the seam being confined. And if you remember at school doing science and giving you a plugged syringe and you're trying to pull the thing out, that's effectively what we were trying to do. So there was water in there. We knew it was a transmissive system because we knew it was full of tunnels and workings. It was worked by room and pillar. But getting it to give that up, it did give up some, but it wasn't as efficient as it could have been. So we put in, what we did was we actually, because we had 2 abstractions, we pulled the casing back in one of those abstractions to expose the high main seam and the Hutton Seam, and that allowed an interconnection between the 2. So that effectively depressurized the Hutton Seam a bit, and then we got this orange curve. So you can see there that the drawdown at the different steps does kind of flatten out and stabilize. So we got much less drawdown, which was better within the limits of the pump and pump depth, and we got much better yields as well. So that was one thing we learned about this project. You may not need to do that for every project. It was specific to this one, perhaps, but it was interesting. And we've had some instrumentation down. We have drilled another borehole now that is purposely for connecting the 2, because obviously the 2 abstractions needed to be used as part of the scheme. So this multi-seam borehole was drilled, and we reckon from some measurements we've done that when it's running, we get around about 50% of the flow rate going down this borehole. When the system's switched off, because the Hutton Seam is obviously under slightly high pressure, it goes back up slightly. So there's this movement up and down through this interconnecting borehole, but it has made a big difference to this project. And I think it's also made things a bit better at Lanchester Wines as well. So it's kind of helped them out as well. So this is where the sites are. So of those polygons I showed you before at the very start, the big red one was up here, and then that kind of orangey one that was beneath it was here. So we actually started drilling off in the Albany Road depot, and we drilled a few boreholes in there, and a lot of stuff was collapsed. It wasn't very good, so we weren't getting very far. So we moved off across the road to this area, and had a lot more success in this area. So the 2 abstractions are located there, and the re-injection, and the interconnecting borehole is just over here in this area as well. It's not marked on there. So we ended up drilling about 13 holes to end up with the ones that we had. One of the failed ones we've kept as a monitoring well. So we have about 5 boreholes now that, I'm thinking 6 because we have a monitoring borehole there of our own as well, but there's 5 that were kept, 2 abstractions, 1 injection, the interconnecting one, and 1 that we've retained for monitoring going forwards. And when you look at the seam plans, the ratio of pillar to void is about 1 in 3, and our drilling success rate was about 1 in 3. So it kind of works out about right when you're trying to hit these targets and you don't know exactly where they are, because it's difficult to georeference the plans accurately because they're so old. So this is a conceptual model of what we've ended up with, so it makes it a bit easier to kind of visualize what's going on. So we've got the 2 abstractions, and Gateshead very kindly, because the gentleman I mentioned that I used to work with passed away very suddenly, and obviously it was a terrible experience for everybody concerned. But when we went back for our next meeting with Gateshead, we'd been calling the boreholes like A, B and C. They had put his initials to them, which was really lovely. So they're all kind of named after him now, which is great. So, and we've ended up now with this situation where we've got the 2 abstractions there, and there's gaps in the numbering because obviously the ones in between were the ones we didn't keep, didn't work out so well. And then we've got the re-injection here, and this is the multi-seam one, so you can see how everything's configured. The water's pumped out and goes through the heat exchanger. The heat exchanger at Gateshead takes a bit more than 5 degrees out. So that's another thing you can adjust when you're designing these systems, the amount of water temperature you take out. The greater your temperature drop, the less flow you can have. So that can allow you to reduce the flow rates and obviously reduce pumping costs and lifting water costs. So it goes through the heat exchanger and then it goes back underground. So no mine water goes anywhere near the heat pump, and the heat pump then interfaces with the heat network and boosts the temperature. So I'll go into that in a little while. The temperatures that we had, the high main seam, the top one was about 11 degrees, and the Hutton Seam at 150 meters was 15. The water in each seam is quite similar in quality, kind of on a first look, because both are brackish, which is not unsurprising when, you know, the high main is kind of in continuity with the river. But the Hutton Seam was much more reducing because it was confined, and some of the isotope data showed a much older, probably formation water, slightly different composition to the high main. We found higher iron in the high main than in the Hutton as well. And throughout the test pumping, we were taking samples from various points in the system and also in the River Tyne, upstream and downstream of the site as well. In a lot of instances, the metals concentration in the mine water was less than in the Tyne, because obviously the Tyne's got a lot of historic issues with metal contamination. So we do all that so that the Environment Agency are happy with how we're operating it. So this is the heat pump that they have at Gateshead now. So they've built another energy centre to house these. It's not actually that big considering how big the heat pumps are in terms of, you know, the megawatt outputs. There's 6 megawatts from them. There's a 8-degree temperature drop across the heat exchanger, and that allows them to operate at a coefficient of performance of around 3. So for every kilowatt of electricity they use to drive the heat pump, they get 3 kilowatts of heat out of it. It uses ammonia as a working fluid, so there are restrictions on who can enter the building. Obviously having that present causes some extra health and safety things that you have to think about. It won't run continuously at 6 megawatts, so a lot of people think, oh, if you're taking all this water out, how is it going to heat back up again? This scheme will probably run for about 2,500 hours a year. Eventually, it's going to ramp up over the next few years because some of the loads that will be connected are still being built. And we estimate that around about 400,000 cubic meters will be circulated around that system annually. And they should have carbon savings around about 1,800 tonnes per year. So the challenges and the lessons learned, I would say one of the key things was complexities associated with georeferencing old plans. There's, you know, not much you can really do about that. If anybody's got any bright ideas, or we spoke to oil companies that were interested in diversifying, you know, and they had various things, geophysical techniques they could suggest, but the cost of them was more than drilling the boreholes. So you've got to kind of weigh that up. Sometimes if it's not too deep, maybe drilling is the best way to find these things. Although we've got the plans, we don't know exactly whether the plans were worked, whether coal was overworked and coal was robbed from pillars and things like that, and we don't know the condition, given their age, you know, what's happened post-closure, have they sealed up? And we did find some sealed up workings when we drilled. So that meant there were extra boreholes that had to be drilled. And also because of the kind of hydraulic performance that I mentioned, we had to put in the interconnecting borehole too. So in kind of, if you want to do these schemes, there's regulation and licensing process to go through. So the Environment Agency are the regulatory body for England, and then it's SEPA in Scotland and NRW in Wales. So the various processes you go through: a consent to investigate before you start drilling. And once you've got your boreholes and you know how your scheme is going to work, then when they're operating, you'll need to operate those under abstraction licenses and discharge consents. And it's important to note that the EA are very much the regulator, we're not. So, you know, it's really up to them to say how this is done. We give permits, so permission to drill into and enter the workings, and we've also developed a heat access agreement, which is a charge that will be made for accessing the water for heat recovery. Again, as part of our cost recovery kind of, I don't know what word for it is, but the kind of remit that we have for cost recovery. It's not intended to be a money-making thing, it's intended to offset the costs. You should also notify HSE as well. There's various conditions on when you need to do that, like the number of people you've got working on the site and things like that, but you should notify them within the start of drilling, and the British Geological Survey will have your borehole logs as well. They want those to go on their system. And then long term, the EA and Coal Authority are likely to put together a monitoring programme for anyone operating these schemes. So this is kind of a new area for the EA and for ourselves. So there have been a lot of collaborations. We don't get involved in the licensing. We have a separate team that do that, but they are working very closely with the EA to make the process as streamlined as possible so that, you know, everyone can get through the process with, you know, in the best way. So the next step for us, obviously the scheme at Gateshead is just waiting final kind of regulatory approvals now, so that will be running within the next few weeks. It runs a couple of hours a week just to you know, keep pipes and things happy, but that will start running properly soon. There's the system working at Lanchester Wines, and between that we're going to drill some boreholes in all of these little locations here. Certainly in these two, we're not sure if we'll have time to get, this one's a backup one, and this one is very near the train track, so we might have to move that one because the network rail process is unbelievably, takes a long time to sort out, so we think we might move that one, but we're going to put some boreholes between the Gateshead scheme, which is up in this bit, and then Lanchester Wines is down in this area, just to see what happens hydraulically when both systems are running, and also see what happens with temperatures and things as well. So it's some R&D that will enable our licensing team to think about the proximity of schemes in the future. The data will be open access, so anybody who's doing research or is interested will be able to download it. And it's kind of, it'll sit quite nicely alongside the work that BGS are doing at UK Geos, where they've got some monitoring boreholes and a site there for mine water heat. That's not got a commercial scheme connected to it, so there's the opportunity there to do far more experimental stuff than there will be with ours. Ours is more observing what's going on and learning from that. So the two will work quite well together. So the Gateshead scheme is the first of a kind mine water heat network in the UK, and at 6 megawatts, it's probably the UK's biggest geothermal scheme. It was an extension to an existing scheme, so they doubled the size of the heat network and brought in 6 megawatt heat pumps. The local authority has generally been very forward-thinking throughout the past few years. They've led quite a lot of new and sustainable energy opportunities. And it's been quite quick to do in terms of a big energy project. So it's been around 3 years from start to finish. And it's proved the concept. We've also proved the concept. We've used heat pumps in some of our own buildings running off our mine water treatment, just at small scale. But hopefully it's shown you that there is potential to reuse what's been seen as a liability as a future heat supply. And when you think of the effort that went into creating it, it's really nice if we can repurpose it for something else. And this has very much been a collaborative project. We were involved in the subsurface work. There's obviously topside designers, the drillers. There's all kinds of the engineering contractors, people who came and put the pipes in the ground. And some of them are in this final photo, and every one of them could probably come and talk to you for an hour and all have great stories to tell about it. So it's very much collaborative And certainly internally, there was a team of 3 or 4 of us working on this as well. So thank you very much for your time. I'm happy to take any questions.
Yes, that's wonderful. Thank you very much indeed. That's wonderful, Charlotte. You have given us a lot more information on what's happened in the last few years, and it seems to have advanced very, very quickly. So yes, questions from the floor. Could you please quote your name and who you're with?
There was none.
Oh, we can see.
Yeah,
We can see each
Time for a beer.
Any questions? Good. Thank you.
Oh, I think it's for the Zoom people. It's just for the Zoom people, and they can.
Hi, Lynn Chapman, Newcastle City Council. I'm here with Matt, who's from the Environment Agency. We're working on a groundwater project, as you know, because you're on the steering group for that. And when you mentioned about getting some bespoke feedback from the mining and things like that, our comms side is now well underway. On that, we've got an event coming up in the Common Room in April, and we're hoping to gather as much information from that as well. So I'm just wondering, like, it's a bit of a personal plug for us. I'm just wondering if we can try and get together, and maybe even with yourselves, because we've also got the Innovation Festival coming up with Northumbrian Water, and we've got a tent for that. And that, I've really encouraged people to sign up, because it means that we can get more. It's a sprint, it's very intense, it's a 3-day thing, but as many people that come along as possible so that we can actually develop our knowledge further. But we're really keen to get with you so we can help develop those comms on the bespoke side of things for the mining, because a lot, what was really interesting what you said was the mining areas now, you're looking at 3 generations that haven't had people working in those areas, and it would be great to try and work on some of these schemes with yourself. And that's I think we would like to know more about the comms and how you're going about that, and any work we can sort of do together. I can pass on my details at the end, because it would be really, really good to get as many people along to, especially to the Innovation Festival in July with Northumbrian Water at the Gosforth Racecourse. I don't know if anybody knows of it, but it's a 3-day sprint, and it's brilliant. It's just people coming together, putting as much ideas, and for us it's on groundwater and mining. But we would like to know more, because we would like to plug more of your work on our comms page.
Certainly put you in touch with our comms team for that.
Thank you very much. Anyone? Norman?
Don't ask a difficult one now.
Norman Jackson, Seaton South. Charlotte, one thing that always interests me is the licensing to drill. What is the penalty if somebody decides not even to contact you? Has anyone ever been prosecuted for drilling holes into the ground?
I don't know, actually, because I'm not in that
Because,
team. So,
quite frankly...
yeah, how would you know?
Well, exactly.
Yeah.
I know several schemes that are operating where people have made no contact at all with the Coal Authority or the Environment Agency.
And in some cases, they might not know they need to as well. So
Well, exactly.
yeah.
But the one thing that should be made very, very clear to people, that if you are drilling a borehole into coal measure starter, that is a mine working, with all of the implications that has.
Yeah.
Thank you.
Thank you. Good point.
Might as well ask a question. Stuart Porthouse, Sunderland. Great paper, Charlotte. I know
Thank you.
I've been listening to you here for the last nearly 20 years, I think. Goes
Thanks
back
for
that
still
far.
coming back.
I was talking to an officer from Sunderland, and I've just heard somebody from Newcastle, and you've been on about Gateshead, and we were discussing this issue about sharing all the information, coming together as a group, so that, you're not all, ploughing the same furrow, to try and find out something new. It seems to me, and don't depend on politicians because you can't rely on them, somebody needs to create, probably under the Coal Authority banner, some organisation that recognises what everybody's doing, and you come together as one. It amazes to me that what needs to be done now.
There is a mine water task force that was set up by the North East LEP. That hasn't met for a while, but that was a really good group, and that had a lot of the local authorities on it. And what we've been doing, I mean, Jim at Gateshead is very open to sharing, and we've done a lot of visits. So just the other week, we had somebody up from Barnsley. We had a group from Barnsley Council, and I took them to Dordon first, which will be the source of the Seam project, so they could see that. And then we brought them up to Gateshead, and they went away saying, yeah, we want one. So we do quite a lot of that, but it's done informally. But when people do ask, we do try and accommodate. And I think it'd be good to try and do it through the task force, or it's how best to do it. But we're certainly up for doing it. I mean, we're a smallish team, and same at Gateshead, it's a smallish team. But as you say, to have somebody specifically doing it would be really good.
Peter Graham, Sunderland City Council. You mentioned about the connecting borehole helping with the Lanchester Wines issues, and obviously that's been quite widely reported. Do you think some of those issues have been down to pressurisation?
I think, I don't really know because we've not been involved in their scheme, but I know that some of the boreholes didn't hit the workings because I think well, I think the mine plans probably weren't interpreted maybe as well as they could. I think they appreciated there was workings, but maybe not the specific targets they were aiming for. I know they've got other drillers on board now who are sorting things out for them, I think. But yeah, I think a lot of those, they just weren't in the right place to start with or in the right horizon. But as I say, I haven't looked at them in detail because we've not been formally involved in that one.
Last question. Which countries are you knowledge sharing with? You said earlier on that you were where you've closed and capped some of the shafts, which was a shame that you were actually knowledge sharing with other countries. I was thinking, is it like India or China or?
Well, Norman's paper was due to be in Russia, wasn't it? So, wait, you can... Yeah.
For example, we have got 5 shafts, and none of them are accessible.
Yeah, which is a shame.
Even to do exactly what the water's doing in those shafts is such a key issue.
Yeah. And from our point of view, we're working as well with people in Poland, and on the academic side, there's some academics in Germany doing a bit of work as well. So, and we just got a kind of international person who's got the remit of engaging a bit more. She was formerly at DIT, and we did some workshops with her where we had 30 or 40 countries there. So she's now following with some of those people to see whether they want to kind of knowledge share with us.
It's a question from our president. What professional skills are needed to support these schemes, and how can NEIMME help with developing these skills to support this sector?
There's a range of skills, really. I think what's key and what we risk losing most importantly is the mining information, knowing how to interpret a mine plan, knowing what all the things on it mean, knowing where to look for them, all of that stuff. I think that's really key as a basis. And then we'll obviously need more people experienced on the drilling side if we're going to do this, roll this out more widely, and more people on the installation and heat pump side as well. But I think in terms of what you can do, I think making that mining information accessible and showing people how to interpret it would be great. It's just because the online people can't hear.
just in terms of the jobs and things like that, one of the things I learned at the last Innovation Festival at Northumbrian Water was when you talk to children, they don't actually know what jobs are out there, and they certainly don't know about STEM jobs. So my kids are 7 and 4, and I ask them what job you want to do. It's usually like fireman, policeman, something like that. I know from when I did my engineering degree, you've got things like thermodynamics and stuff like that. So what specific kind of engineering posts would there be in the mining industry?
I think, I mean, a lot of it is, you think of the places that offer just stuff like earth science now, there's very few schools. I mean, I went to a school that did earth science, but not many did. And it wasn't like a good school or anything, it was just a normal comp, but we were lucky that we could do geology there. And so that's not offered, and it's often rolled in with geography, and even in, degree level, things are not, maybe geology departments have been subsumed by other departments. So there's geo skills, there's engineering skills, and kind of geoengineering, not as two separate things that need to be addressed. And I guess I've been into a few primary schools and talked to kids about what we're doing, and they're horrified when I show them pictures of miners with coal. They're absolutely incensed. They shouldn't have done that. And it was like, well, they did it because that's what everyone was demanding, and that's what our economy was wanting. People wanting energy, they were wanting to progress. So that's why they did it. So yeah, there's lots to be done on the education side, and we have done some work. And Durham Uni, who I was with, are doing work with a group called Oasis, who do a lot of sustainable learning with kids. And they did if anyone's interested, it's on YouTube. It's Hordern Primary made a plasticine animation of using the Hordern mine water for growing food, and it is just lovely because they've made all these weird and wacky characters, and they're all moving boxes of food around and stuff. So but that group are doing a lot on mine water. But again, they're a small group, so there is lots to do on education at every level. Yeah, if you go to YouTube and look at Oasis Northeast, it will probably come up as under one of their videos. They're not paying me to say that, by the way.
Another question, Charlotte. Hi, Andy Fudge, Cathy Associates. I was just wondering, on your slide about the data loggers for the water pressures in the two seams, and the unconfined and the confined, you mentioned being able to determine that one was confined based on the difference in the response in the data logger. Is that easy to pick out? Are they orders of magnitude different, or is that quite a hard kind of thing to be sure of?
We picked it out initially from the rest water levels being different. So we knew, because the water level in the deeper seam was higher than it was in the shallower seam, we knew that that one was likely to be confined. So it was kind of confirmed by its behaviour. We had the suspicion it was, and the test pumping behaviour confirmed that it was.
Peter Thompson, Cathy as well. With the COP ratio of 3, I guess obviously at the moment with prices, a kilowatt of gas is, well, a kilowatt of electricity is more than 3 times a kilowatt of gas. So you're kind of in the same ratio in terms of your electricity costs compared to, if you've got the same kilowatts of gas. So, and obviously at the moment, electricity prices are pretty much locked onto the gas prices in that sort of ratio. So, does this need, for a more widespread economic rollout, would it need significantly cheaper electricity prices if you work on those similar sort of ratios?
And what they've done is they've put in some quite big PV farms. So there's 2 big solar farms that are going to
link
offset
it to your own electricity scheme as well.
Yeah, and if you were, because of the way the existing network was, they had to use a centralised system with the gas engines. But if you were doing a decentralised system, you could maybe get away with lower temperatures in the network, which means the heat pump COP might be a bit higher as well. So you could design it to work differently. I think our funding at the time, it doesn't support cooling, and I don't think it supports decentralised. So and because they had the existing system, that's why they made that choice. But that works. There is a business model behind that works. I don't know what it is, because obviously that's something they deal with, but that does work for that project. but having their own electricity must help with that as well. And they have some from the CHP, but obviously that will reduce as they use that less in future.
Another contribution from our president. NEIMME should take the initiative and arrange such an umbrella initiative to take over from the task force. Would you be happy with that?
Well, it wasn't my task force, but yeah, I'm sure they would welcome that, because it got quite a big group, which was really good. And I don't know why we haven't met for a while. I'm not sure, but yeah, it would be good to pick that up again, and great to have NEIMME involved.
Oh, hi, Malcolm Atkinson, NEIMME. Going back to Gateshead, I am right in thinking that you're only going to be running it for so many weeks or whatever of the year, presumably through the winter period.
Yeah.
Right. So on that basis, bearing in mind the heat recovery back into the water, how many years are you predicting that this could run, or is it forever?
That's a good question, yeah, and that's something we hope the Living Lab might tell us, because we just don't know what the recharge is like. We have got a group of students at Durham who've been modelling the project we're working on with Sunderland, and they've also done some work on, I think there's a PhD student going to look at Gateshead, and they've also done another project in Durham that was done a while ago. So it is a good point, how quickly do these things heat up. I think if you've got a system where you can have cooling and you can put warmer water back in the summer, then obviously that's going to preserve the life of your reservoir. But I think the BGS on general geothermal did an estimate of 100 years resource. That's without, sticking it back in, but that's very generic for the whole of the UK and all of the geothermal resources. So I think with careful management, the design lifetime of this system is 40 years. So obviously they're hoping that would run for that. And yeah, I think there's quite a lot of flow through that system because of the type of system it is. So hopefully quite a bit of recharge of heat, but time will tell. And yeah, it's a good question. I'll come back in 10 years and we'll see how it's doing.
Steve Sansom. You mentioned one of the difficulties is knowing where the coal seams are and understanding where they are, but I wondered, how did they find them in the first place? And can we not use the same techniques to re-find them?
Good question. Yeah, I guess. I think it's going back in would be difficult to go through the same process, but I guess they were found from outcrops. And then there'd be bell pits, wouldn't there? And then bell pits.
These are 100 metres deep, aren't they? So it'd be,
yeah, but they would have started with the shallower workings, and then as technology advanced, they will have gone deeper. So if you look at the closure, the map of, I think it was here, was it? I saw a map. No, it was Durham Mining Museum. They showed me a map of the closure dates, and you can see that the closure dates get younger as you go east, because obviously the mines got deeper, technology got better, and the ones on the very western edge of the coal field were, abandoned first because they were worked first effectively, and then they had to move further east, and as everything improved. So I guess it would have started in those shallow places, and I think areas where bell pits were, I think Stefan was telling me about this the other day, were then turned into, areas where you'd maybe do room and pillar, and you wouldn't go from surface, you'd work underground. But I don't know if you want to add anything, Stefan, because you know loads about this. But,
I mean, you said you talked to the oil industry about it, and they obviously use seismic. Presumably you decided that was too expensive to use.
We've been working with Newcastle University. They put a bid together to do some seismic, but using a novel kind of sensor that would work on just background seismic stuff from stuff going on in an urban area. So they didn't get the funding for that, unfortunately, but it's something they'd still like to do. They did get to try it elsewhere, not on a mining site, but that was hoping to look where there was seams with water in. So that's, and you're looking for a different target now, because of course you're looking for water rather than coal.
boring was used even back in the 17th, 16th and 17th century. The boring technology gradually improved, but from my reading, most of other than very shallow seams, most of the deeper seams were proved by boring, either from the surface or from the base of an existing shaft. The problem with the Durham coalfield, unfortunately, is that the seams are not consistent. They were split, they were combined, they would fade out. The Tyne Basin itself, the central Tyne Basin, seems to have had the thickest of seams. But as you move away from Newcastle, they thin out and sometimes disappear. So it's been a hit and miss thing. A lot of money's been lost, and a lot of money's been made.
We've got time for probably one more question, if anyone's got any more inquiries. No? Oh, we have.
Oh, sorry, yours. Is it yours? Was it? Oh, apologies. Oh. Thanks. Peter Jackson from Durham. I apologise, I missed the very first few minutes, so if you touched on economics, I may be asking you for something I just missed. But given, apart from reducing the carbon footprint, people are going to look for reducing their fuel bills, obviously. Did Gateshead Council have a sort of global budget as to how much we're prepared to spend without giving away any great secrets? And also, if you don't mind me asking, I know Durham University could have put in a scheme at Mount Oswald when you were still there, and for political sort of university political reasons they didn't. But did they ever do any economic studies into the potential actually around Durham City?
In terms of Gateshead, I don't really know. Oh, sorry,
I think your battery's
has
going.
it gone? It's time for me to shut up, isn't it? Thank you. In terms of Gateshead, I don't really know the details of what they set out to do. I know they got about just under 6 million from HNIP, and I think it was about 16 million in total. So the local authority did put in a significant amount of funding as part of the project, and there was other things apart from the mine water aspects. As I mentioned, there's a solar farm. You know, there's other bits and pieces on that scheme. So there's all kinds of things there. But their concept, which they developed in their business model, with the gas engines that they have already and the energy company they set up to service that, was that their customers would be offered 5% less than the market value. And they're still coupled to the gas prices, obviously, because they've got the gas engines, and obviously they're using electricity for the heat pumps. But we were at an event yesterday, and we were talking about deep geothermal, and you could imagine that if you could decouple from those gas and electricity prices, still offer 5% less and track, you've got quite a big potential to offset your capital of doing these deeper boreholes. So there's lots of different ways of doing it, but that was the model they took to track the market price and undercut it by 5%.
Did we have time for one more question, Charlotte? Stefan, did you want to ask a question there?
You beat me to it. By the time I've written the question, you've answered them.
Well, that's good.
One thing, well, two really. The casing, has that been done throughout? It's continuous casing, is it?
It was open in the bottom, into the workings,
So
but
the,
otherwise
through the strata.
otherwise continuous. Yeah, and we used like nice stainless steel, and then on the interconnecting borehole we used UPVC.
Well, the other sort of question, you'll see in that article that I've just dug out, the last 24 hours really, it was regarding a proposal for a Tyne Basin drainage scheme in the mid-19th century. And the numbers in there are quite amazing. The actual volume of the total reservoir, not just the immediate reservoir around Tyne Main, for instance, is absolutely enormous. Tyne Main was one of the collieries that they proposed to use as a pumping shaft in collaboration with 3 or 4 others. And the volume of water that they anticipated being pumped was way in excess of the kind of volumes of water that you're going to be abstracting here. So even in those days, the replenishment rate was enormous. So I'm just wondering whether, in actual fact, you need to use your replenishment borehole, or whether it'd just be a convenient means of disposing of the waste, as it were.
Oh, you mean just dispose of at surface rather than re-inject? Yeah, you could do that. You may need to have the space available to put a treatment system in, and generally the Environment Agency are not so keen on you doing that either, because the quality can be different. So generally their preference is that it would go back underground, and then we just need to, obviously we know it's not consumptive, but then we just need to know what the heat recharge is then.
If the figures in that are anything to go by.
Yeah, some massive figures. I mean, we pump
you won't need it to
I think we pump over 300 litres per second out at Kibblesworth constantly, so 300 or 400 litres a second there, it's a big one. Dordon does 150. You know, so we do pump quite, I think Bates is now up to about 200, something like that, so there's a lot of water being moved. And those are the sites where you could connect something at surface, you know, and you wouldn't need to put the boreholes in.
Well, I think we've had some pretty good questions there, Charlotte.
Yeah, great questions. Thank you,
You've
everybody.
answered them very, very well. So there we are. We've all enjoyed that lecture this evening. And can I call upon Norman Jackson to give a vote of thanks on behalf of us and the North of England Institute?
Charlotte, can I congratulate you on an excellent paper? And can I also just record this Institute's thanks to the Coal Authority for its support to this building and to our organisation over a lot of years. Your talk tonight's been, you've covered every aspect of something that's very important to this area. There is heat there, and it can be got out, and the challenge that I think it presents us all with is extracting it at a price that's acceptable to the current market. And I would caution many people, because it's a difficult problem, started by where are the workings that can produce the water? Secondly, how can you drill them? And you've discussed that. And once you've drilled them, how do you get it to the surface? But more importantly than that, and somebody raised it over here, is the long term. How long can it continue? Will it continue to be viable? And can it be maintained properly, because it is a moving feast. For example, you cannot presume, and this is for the audience, you cannot presume that the status quo will always remain. It's a moving area, the mine water is continuing to move, the ground is continuing to move, and this must be built into all your schemes. But I think in your talk tonight, you've highlighted all the attributes and all the problems, and thank you very much. And I would like the audience here to show their appreciation in the normal manner.
Thank you.